Okay, class, so now we're going to start moving into a different form for absolute value functions. So what is the parent function of an absolute value equation? So we know this as f of x equals the absolute value of x. So then let's review what happens to these parent functions with these movements. So when we have x minus 5, that means we shift right 5. X, absolute value of x, and then we have the plus 9, so that means we shift up 9. When we negate the absolute value, we reflect across x-axis. This one, there's two things going on. The first thing I notice is there's that vertical stretch by 3. And then it looks like we're going down 2. So this one's a vertical compression by 1/4. And then the x plus 6 is left 6. For f, I first noticed the negative, so that means we reflect over x-axis. Then I notice we're going to go left 7, down 2. So we've been used to this because we've been working on that the last couple lessons. The horizontal and vertical shifts describe the location of the vertex. So then we have vertex form, which tells us exactly what the vertex is. The vertex form of an absolute value function is written as f of x equals a, and then here's the absolute value sign, x minus h, absolute value sign, plus k, where h, comma, k is the vertex. So remember, it's always x, y, so h would be my x value, k would be my y value, and just remember, it's minus h for that positive. So if it was minus 3, my h would just be 3. If it was plus 3, then it would be negative 3. A is our slope to the right side, and negative a, so you just do the opposite, is the slope on the left side. So let's use this to help us graph. So let's do our first one. So here, the first thing I'm noticing is what is my vertex? And I see the minus 2, so my x value is just a positive 2. And then the minus 4. Notice it's plus k, so that means our vertex is at negative 4. So let's plot that first. So we go right 2, 1, 2, down 4, 1, 2, 3, 4. Now a must be 1 because there's nothing in front, so that means our slope is 1 going to the right side. So that means we go up 1 over 1. On the left side, it'll be negative 1, so we're just going to go in the opposite direction. And we should know this because, right, aren't all our absolute value functions always a v? So then I connect my dots, and that makes it way quicker to graph these functions. So let's do number 2 together. First thing I notice is we need to find out my vertex. H would be negative 5, because notice the plus 5, that plus 5 makes it a negative 5. There's no plus k, so it must be plus 0. So my vertex is at negative 5, 0. So 1, 2, 3, 4, 5. Now what's different about this one is I do have a slope of 3. So that's on the right side we always start with. So 3 would be going up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1. And then let's do the opposite. Up 3, 1, 2, 3, left 1, 2, 3, left 1. And we have our beautiful graph. Pretty easy. So we started off easy with 1 and 2. Let's look on the back. We're going to skip to number 4, just because now I threw that negative sign at you. So that's one thing I'm noticing here. But let's start with our vertex. Our vertex here is going to be 6, 0. Right? Remember, there's nothing there for k, so it must be a 0. So let's plot that point. 1, 2, 3, 4, 5, 6. Now that negative sign means my slope to the right is -1. So that means we're going to be facing down. Slope to the left is +1. So we have to go in the opposite direction. Now my other hint is, remember when we were learning from the parent functions, if you negate the outside of an absolute value, you have to flip it over the x-axis, so you kind of already know that's going to happen, but it's nice to know that it's a -1. So that's why on the right side it's pointing down. Let's do number 6 so that we get more practice to having a different slope than what we're used to, and it's negative, so I kind of like that. So for number 6, first let's kind of figure out our vertex here. There's nothing next to my x, so our x value must be 0. But then notice y is +7, so our y value is 7. So I'm going to plot that. So 0, 7 is 1, 2, 3, 4, 5, 6, 7. Now the tricky part is I have a negative slope, so I know I'm going to be facing down. And my slope here is 3/4. So I'm going to go down 3, 1, 2, 3. Right 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So then do the same on the opposite side. 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Oh. So it's not that bad. Just know when you have those negative slopes, you're going to be facing a totally different direction. We're going to skip to number 8. So now we have a piecewise. First thing when I have piecewise is I need to split my graph up with dotted lines with barriers. So x is less than or equal to -4. So the first thing I know is it's going to be a closed circle. So let's find -4. 1, 2, 3, 4. And I'm going to draw some dotted lines. So that's my first barrier. From -4 to 2 are open circles. So -4 to 2, 1, 2, dotted line. And then 2 on would be closed circle. Okay, so let's start by graphing our first equation, which of course is an absolute value one. So for this one, your vertex is -1, 5. Now remember, this is everything to the left. So let's see, -1, 5, 1, 2, 3, 4, 5. So even though I'm putting the dot here, I'll erase it afterwards, but I want to be able to get this side. My slope here is -1, so it's going to be facing down. So I'm going to draw some dots. Alright, so notice I have all these dots, but this has to be everything less than -4, and it will be a closed circle on this line. So I'm going to erase everything on the right, and I'm just going to connect these dots over here. So I got the first part of my piecewise. 3 if -4 to 2, so we got to go up 3. So that's an open circle to an open circle, and it's just a horizontal line. So everyone sees that. I'm going to make that a little bigger. That's just a horizontal line. The last one is -x plus 7, which is just slope is -1. My y-intercept is 7. So 1, 2, 3, 4, 5, 6, 7. I'm going to just put the dots, even though on the left side I'm going to have to erase. I'm just going to draw my dots. Remember, it's going to be a closed circle right on that dotted line. I'm going to erase these dots. And I'm going to draw straight down. So not too shabby, just a lot of work because you got 3 lines to graph. The last one is an inequality, so we do have to do the shading and the dotted lines. First thing I notice here, it's going to open circle, so that means dashed. Let's do our vertex. Our vertex here is 5, 4. So let's graph that. 1, 2, 3, 4, 5. Go up 4. 1, 2, 3, 4. Next thing I see is my slope is -2. So it goes down to right 1, down to right 1, down to right 1, and the same in the opposite direction. And remember, negative slope means we're flipping it down. And I'm just trying to be consistent. So back to my notes, because it's an inequality, I'm going to dash my lines. And then y is greater than, right? The alligator's eating the y, so everything above will be shaded. So now we could use this vertex form to make graphing way easier.